Hi all, here begins our first video in the BNB Chain development tutorial series. It is also the second video about Solidity programming language. In the last video, we discussed the types, variables, and control structures in Solidity language. And in this video, we will start handling contracts. We will talk about structure of contracts, state variables, functions, and function modifiers. So first, contract. Contracts are basic components that constitute smart contract. It is also the basic component in Solidity language, just like class in other languages. Contracts have state variables, functions, function modifiers, and events. It also has inheritance and polymorphism, just like other OOP language. State variables, they are those who are permanently stored in the contract storage. An example is given below. We have a contract called coin. There are two state variables present. One is called mint. It is of type address, and its visibility is public. Another is called balance. It is a mapping from address to unsigned int, and it is of visibility private. We will talk about visibility in the next slide when we talk about functions. But here, public means it is accessible from outside of this contract, and private means it is not accessible from outside but only inside of this contract. Then we can get into functions. Functions are executable units of code. They are usually defined inside a contract but can also be defined outside of contracts. To declare a function, use the following syntax. It is very complex, and we will decode it in part by part. So first, you put a function keyword here, then you give the function name. After function name, you put a parenthesis that will include the type of parameters. Then you give visibility, private, internal, public, or external. And then you can state the mutability of this function, pure, view, or payable. Finally, you give return types. Here, private, internal, public, or external, the visibility is mandatory. If you do not give one, the default one is public. Pure, view, or payable, and return type are optional. If you cannot declare anything about the mutability of this function, or this function is a void function that does not return anything, you can ignore the corresponding part. An example here of declaring function. A function called bid is declared inside the contract called simple auction. It has visibility public, and it is declared payable. You also get a helper function outside, just called helper, that will return twice of the parameter. You can see that this follows the syntax that we talked about in the last slides. Now let's talk about what each part means. First, the visibility. In EVM and in Solidity, there are two kinds of function calls. One is called the external function calls that will create an actual EVM message call, and internal ones that do not. So it's not an EVM message call, but just a call inside this contract. Furthermore, when talking about inheritance, the functions can be made either accessible or inaccessible to derived contracts. Then this will give rise to four types of visibility for functions. First, external one, the most outside one. These are part of a contract interface. It can be called from other contracts and via transactions. Note that an external function cannot be called internally. So suppose you get an external function called f inside this contract. Even inside this contract, calling f is not going to work. It will give you compile error, but this.f will work, and this generate an EVM message call. So it's called from outside of this contract through message calls. Second, public. They are a part of the contract interface. It could be called either internally or outside, externally via message calls. Note that public functions are not visible in derived contracts. Third one is called internal. Internal means it can be accessed only from within the current contract or contracts deriving from it. It cannot be accessed externally through message calls. Finally, private. This is like internal, but it is not even visible to derived contracts, so only the current contract, not anything else. For functions outside of the contract, also called free functions, it always have implicit internal visibility. So what the compiler does is, suppose a contract, some function in the contract used a free function. So then the code of that free function is duplicated and copied into the contract called it. So then it has internal visibility when copying in. Note that making something private or internal only prevents other contracts from reading or modifying the information, but it is still visible to the whole world outside of blockchain. So internal and private here only matters like when you think about programming or contracts, but outside the blockchain world you can still access and read, modify these. Then we can get back to state variables and talk about the visibility for variables. Visibility for variables is pretty much the same as those for functions, but one difference is that visibility for variables cannot be external. The reason being, external functions serve as public interface, and it could be invoked through message calls, but you don't do message calls for variables. That's why it cannot be external. However, the getter function of state variable can be external, and it actually the compiler will automatically create getter functions for public state variables, and it has external visibility. What it does is, if the symbol is accessed internally, that is without this dot, it evaluates to state variable. If it is accessed externally with this dot, it evaluates to a function, to an external function. An example is given below. You have a public state variable called data. If you use data equals 3, then this will be evaluated as internal access. You modify the value of data. If you use this dot data with parentheses, this will be understood and interpreted as an external function, the getter function of the public variable data. So then we're done for visibility: external, public, internal, and private. Next, we will talk about state mutability. These declares the feature of the function. First, payable. Payable means that when calling this function, one can send ether together with it. If some function is not declared payable, then calling this function cannot receive any ether, and it will give an exception if that happens. One example here is we have a contract called sync. This contract will keep all the ether sent to it with no way to get it back. It declares an event called received, means like it tells the EVM it received something. Then it declares a function called receive, having external visibility and declared payable. Upon receiving, it will emit an event called received. Notice that here, before receive, there isn't a function signature. The reason of this is that receive is a reserved word, is a special member function that of contracts called the receive ether function. This function is executed whenever the account of contract or the address of the contract receives any ether. Some special functions do not have to give the function signature, but normally when you want to declare a function, you need to have a function at the very beginning. Next mutability we'll talk about is called view. View means that this function is only gonna read, but not gonna write or modify to the state of this contract. What does it mean by modify the state are the followings: writing to state variables, emitting events, creating other contracts, using self-destruct, send ether via calls, calling any function not marked via or pure, using low-level calls, or using certain assembly. If none of this happens, then this function not changing the state of the contract, it can be declared view. Pure is something stricter than view. Besides not changing the state, it promises not to read from the state. So we talked about what does it mean by modify the state just now. Reading the state is defined as follows: reading from state variables, accessing address this.balance or any address.balance, access any member of block, tx, or message, but you can access message.sig and message.data, calling any function not marked pure, and using inline assembly that contains certain opcodes. These are understood as reading from the state, and if you do this, it's not called pure, otherwise it can. In particular, it should be possible to evaluate a pure function at compile time, given only its input and message.data, without any knowledge of the current blockchain state. Thus, reading constant might still make it not pure. An example of pure function we seen just now is just like given x, return multiplication of x. So it could be like mathematical expression or anything. These can be declared pure. Note that pure and view functions are able to use the revert and require function to revert potential state changes when an error occurs. We can get a quick review to this function example. They should look more understandable for now. Inside this contract called simple auction, we declare a function bit was public. That means it can be accessed internally or externally. It is payable, means that when somebody calls bit, it can send ether together with it. You get a function called helper outside. It is pure, means that it neither read or write to the state of the contract. It returns an unsigned int. It is declared outside of the contract, so it is a free function. Any contract that calls helper will get a duplicate of the code inside this contract. Then we are pretty much done for function part. We can talk about function modifiers. It is a feature provided to change the behavior of function in a declarative way. Say like you use a modifier to say this function can only be run when the sender is owner, so that you can check a condition before executing the function. Or you can say I'm going to run this function several times, so you can have a modifier say like run 10 times. That means run the same function several times. Note that modifiers can also take parameters, and they are inheritable and may be overridden. We will talk about inheritance and override again when we talk about contract inheritance. The syntax of function modifier is as follows. So here is an example. It declares a function modifier called only owner. So first you say modifier to tell the compiler you're declaring a function modifier. Then the name of this modifier is called only owner. And then you have this underline here. This underline is where the modified function's code will appear. So in this declaration, you declare a function called destroy. It is of type public, and it uses modifier only owner. It is possible to use these modifiers inside the functions. And you call self-destruct owner. That means self-destruct and send all the remaining ether to the address owner. And what it actually does is when somebody calls destroy, it will first go to the modifier and say require blah blah blah. It will require message.sender equals owner. So only owner can call self-destruct. And then after this is finished, the code of this function is copied to this underline part. And this is where it will be executed. It will execute self-destruct, send the remaining money to owner after running this check. That is pretty much all for today. Today we talked about structure of contract. We discussed variables, we discussed the syntax of functions, their visibility and state mutability. Finally, we introduced function modifiers and seen a couple of examples. In the next video, we will discuss special member functions inside a contract. This will include the receive ether function we've seen just now, and we will also talk about contract inheritance in Solidity language. See you in the next video.